I just sent out an exercise set on some basic derivative problems, and I'm going to work a few of these sample problems out. I think problems 2, 4, and 7. So here's problem 2. One thing we can look at is, and we need to look at with all these problems, how would we classify these problems? Well, problem 1, what do you have? Well, you have a product of two functions. And how do you know you have two functions? Because we can box in one and the other. So if you have a product of two functions, what is in play? What would help? Product rule. But as I said, I'm going to do problems 2, plan to do problems 2, 4, and 7. And so here we have y equals 2 minus x over 3x plus 1. And what we have here is not a product of two functions, but a quotient. So we have this low, I'm boxing in purple. This high one, I'm boxing in blue. And so the way I like to do is I'd like to just organize this. And so the low, I'm going to write this down as 3x plus 1. That's our denominator. And the derivative of our low is going to be 3. Our high is going to be 2 minus x, and our derivative of our high is equal to the derivative of 2 minus x, which is going to be negative 1. And so y prime is going to be low, and low, as we mentioned, is 3x plus 1, d high, which is negative 1, minus high, and high is 2 minus x, and d low is 3. And all over low squared. So 3x plus 1, 23x plus 1 squared. And then typically a problem like this, it's going to come out maybe as a multiple choice problem, so we can distribute the negative 1 to these terms here and the 3 to these terms. And so just writing it out, simplifying, we have 3x times negative 1 is going to be negative 3x, and then negative 1 times 1 is going to be minus 1, and then we have minus, okay, we have 2 times 3, which would be minus 6, and then we're going to have minus negative 3x, right, 3 times x, and a minus minus, so it's going to be plus 3x, and all over low squared, which is quantity 3x plus 1 squared, and just canceling out, we have negative 3x and 3x cancel each other out, and we have left y prime equals negative 1 minus 6, so we have negative 7 over quantity 3x plus 1 squared. That's going to be it. Now, this negative 7, there's nothing I can see in the original that tells me, hey, negative 7 is going to be what you have left in the numerator of its derivative, but that's what it is. Okay, now to problem 4. We have, now at first blush, this would look like a quotient of two functions. In fact, you could work it out. So if we have this as a denominator and then 2 as a numerator, and we can go ahead and use the quotient rule for this one if we'd like, right? But one thing we can do is we can rewrite this function as 2, and we're going to take this 5x 0.5x plus 1, and we had to the third power down here, we're going to make it to the negative 3 power up here in the numerator. Okay? So y prime is going to be equal to, we take this negative 3, multiply it out front, times 2, and then we have 5x plus 1, and what we're going to do is we're going to subtract 1. It's negative 3, we multiply it out front, and then we have negative 3 minus 1, which is going to be to the negative 4 power. And then times the derivative of the inside, and the inside here is going to, derivative of 5x plus 1 is 5. Oops. Yeah, there we go. Okay, 5x plus 1, that's going to be 5. And negative 3 times 2, this will be negative 6, times 5 will be negative 30. That's y prime. And then we're going to have just this 5x plus 1 to the power of negative 4. And if we wanted to, we could drop this 5x plus 1 down in the denominator again and make it negative 30 over this 25x plus 1 to the 4th power. So, but that's 4. Next, I said 7, did I? Yeah. Okay. Now this one here, this is to the 5th power, so I'm going to rewrite this and what this really means. It means you have sine, and you have this 3x minus 1, and what this 5 here means, it means the whole thing to the 5th power. Okay? So, f prime of x, which is our first derivative, is equal to, we're going to take this 5 out front, and then we're going to have 5 times sine of quantity 3x minus 1, and then what do we do to this 5th power here? Well, we make it to the 4th power, times the derivative of the inside. Well, what's the derivative of sine? Well, it's going to be cosine. So we're going to say cosine. And cosine 3x minus 1 times, yet again, the derivative of this inside, which is 3x. Well, 3x minus 1 is what's inside, and 3 is the derivative of that 3x minus 1. So this unravels a whole bunch of stuff, doesn't it? Now, just kind of simplifying here, f prime of x, we're going to have 5 times 3, which is 15. And then we're going to have, we'll just write out what we have left here. This, I'm going to put it back in its original form. We'll put sine 4th 3x minus 1, okay, times cosine of 3x minus 1. And that's going to be it. So those are a few of the problems. Good luck, and thanks for viewing.